So the question I chose was, determine the values of m and n so that the polynomials 20x cubed plus mx squared plus nx minus 30 and 10x cubed minus 3mx squared plus 2nx plus 40 are both divisible by x minus 2. So the first thing I did was let f of x is equal to 20x cubed plus mx squared plus nx minus 30, and also let g of x equal to 10x cubed minus 3mx squared plus 2nx plus 40. With these two equations, since they are both divisible by x minus 2 is a factor of both equations. According to the remainder theorem, when a polynomial f of x is divided by x minus a, the remainder will always be equal to f of a. And according to the factor theorem, x minus a is a factor of f of x if and only if f of a is equal to 0. Because of these two theorems, since x minus 2 is a factor of both equations, the remainder will be 0. We then have to substitute x is equal to 0 into both equations and let the other side equal to 0. This is because f of 2 is equal to 0 and g of 2 is also equal to 0. Once we simplify both of the equations so that the only remaining variables are m and n, we can use those new equations to solve for both of the variables individually. Putting both of the equations together, we can see that we can't immediately add or subtract both equations to isolate for m or n. Therefore, we must get two variables of the same value, which I did by multiplying the first equation by 2. That way, both equations now have 4n. We can then subtract the second equation from the first equation to get rid of the 4n, which gives us 0 is equal to 20m plus 140. And after solving for m, we get m is equal to negative 7. After we find m, we can substitute it into the first equation that we got to find n. After substituting and solving for n, we see that n is equal to negative 51. Therefore, the value of m is negative 7 and the value of n is negative 51. I also did a check by substituting m is equal to negative 7 and n is equal to negative 51 into the equations that we got previously, which proves my answers.